Hi, Year 9. So let's start by revisiting something we've learned before. We know that all information or data on our computers, whether it's text, images, or sound, can be broken down into binary numbers. And it's these binary numbers that are what computers understand and use to process data. But have you ever wondered how this data actually gets from one device to another, especially when we're sending it across the internet? Today, we're going to answer the big question: how is binary data sent across the internet? By the end of this lesson, you'll understand that sending binary data across the internet is all about transmission. We need a way to take these binary numbers and send them from one device to another. And this is done by using different types of transmission methods or transmission media. Today, we're going to learn about Ethernet cables, fiber optic cables, and wireless transmission too. We need to learn this because understanding how binary data is transmitted helps us to see how all the different parts of the internet work together, allowing us to communicate, share, and access information from anywhere in the world. And like I said, we already know that text and images can be broken down into binary. Remember that text is broken down into something called the ASCII table, which is just the character set. That is where a binary number has been assigned a character. And images, where just a whole bunch of pixels are given a color. And it's those colors that can be broken down into RGB values that can be, well, shown as decimal or hexadecimal, or of course, binary. Before we begin talking about how these messages or these images are actually transported from one device to another, we sort of need to understand what the internet actually is. The internet is, well, something that we are using on so many different devices now. I mean, obviously we can use the internet on our computers, but on our tablets, on our games consoles, on our phones, on our watches, on our glasses, on our cameras, even in our cars. But the internet really is just a whole bunch of networks of a lot of computers connected together across the globe. But what are they actually connected by? Well, the answer to that is actually cables. They're connected by using wires. And we're not talking about little Ethernet cables that you can see going out of your PCs in a classroom, but huge cables that run underground and under the sea. In fact, here's a map that shows you all of the underwater or under ocean and undersea cables that there are connecting continents and countries together. Without these amazing things, we wouldn't be able to communicate across the globe. But then you go to, remote areas of the world that aren't anywhere near the sea or aren't anywhere near any kind of underground cabling. And if they're not, what we can actually do is bounce them a signal through a satellite. So really good for people that live in rural areas where cables cannot reach. So how can we then send those binary transmissions, those binary bits of data, over wires and wireless connections? Well, first we're going to talk about Ethernet cables. Ethernet cables connect our computers and our PCs and our laptops to the internet, usually. What they do is they use electricity to transmit those binary bits of data, those zeros and ones. They're cables made of copper, and electrical pulses are sent through the cable where if there is 3 volts going through it, then that's a 1. If there's 0 volts, then that's a 0. Computers are then able to translate that into just zeros and ones. In all honesty, though, going back to Ethernet just briefly, is that after a few hundred yards or a few hundred meters of cabling, the signal starts to degrade. And that's why we actually need fiber optic cables. Now, fiber optic cables transmit data using light, and light is much faster than electricity. And it never degrades, which is why all of the cables that you see underground or under the seabed are actually fiber optic cables, transmitting ones and zeros from one continent to another. But then we get to wireless transmission that is connecting our phones and tablets and our laptops to the internet wirelessly. Well, first off, you need to know that actually, when you've got a wireless connection, eventually from like your home router or wireless access point in the classroom, they are being wired very, very quickly. But from your phones to that wireless access point, you're actually using radio waves to send those ones and zeros. Both Bluetooth and Wi-Fi use radio waves to do this. Wireless is nowhere near as fast as fiber optic and nowhere near as fast as Ethernet either. But a massive advantage is the fact that you don't need any cables. This is a GIF showing how your wireless access point, that's the dot that's moving around in that area of a house, shows the signal in every point of a house. So let's imagine for a second that you're in the corner of a room around about here. Let me just point my laser around about here. Let's say you're here in your house. If you notice, it doesn't really matter where your wireless access point is. That area there is sort of a dead spot. It's why in your house, sometimes you just don't get signal in certain areas of your house. It's because those radio waves just can't reach there. They get blocked out by doors and walls and other electronic devices as well.